Okay, welcome back everybody to the Primary Science Podcast. And this is the third installment of this little mini series on inquiry-based science teaching. So I'm your host, Tim, and today we're going to be diving into a super practical episode. So I'm really excited to be introducing our guest, Paul Tyler. So he's a primary school STEM teacher, a fellow of the Primary Science Teaching Trust, and he's co-founder of My Science Club. So Paul, as you can imagine, has a wealth of experience, and today's all about getting into those nuts and bolts of how to use it in your classroom. So if you're ready, let's go and meet Paul. Okay, so Paul, welcome to the podcast. And firstly, I just wanted to say a big thank you for giving up some of your Saturday to be a guest on the show.
So not at all. Thank you for the invite. It's very flattering to be invited onto exciting projects like this.
Thank you very much. How's everything going today so far?
Yeah, good. It's quite early in the morning here in the UK. Got the kids up, got the kids ready to go for their busy day, and just now settled. Looking forward to recording this.
So you wear quite a lot of hats, I think it's fair to say, primary STEM teacher, PSTT fellow, co-founder of My Science Club, and I think some other stuff too. So could you just tell us a little bit about how you got into these roles, kind of your journey with science teaching in general?
Yeah, so my background is in science. I did a degree in biochemistry, and then I worked in the pharmaceutical industry as a molecular biochemist for about 7 years, which is what brought me up to Glasgow. And then following that, I went and worked with Scottish Rugby for a few years as a high performance coach, and then went and did my PGDE and went into primary teaching. And I chose primary teaching specifically because of the variety. I didn't want to just be teaching science. I didn't want to just be teaching PE, which were my other two options. I wanted the variety. My wife's a primary school teacher, so that helped. And I was able to go and spend a bit of time in her school and see. And when I'd worked for Scottish Rugby, I'd done quite a lot of work in primary schools and really enjoyed working with children of that age. So when I went into teaching, I kept quiet at the start about my science background because I just wanted to have that opportunity to teach everything. And I loved teaching writing. I particularly loved teaching maths. I loved teaching art, even though it's definitely not a strength of mine. And about 2 years into my teaching career, an opportunity came up with an organisation in Scotland called CERC, who run science CPD for primaries and secondary teachers, and kind of lead science development across the curriculum in Scotland. And an opportunity came up for a new course that they were running. My head teacher had got wind by this point that I had an interest in science. I think she'd been in to see me teaching some science and realised I might know what I was talking about. So she put me forward for this course. And that really was the starting point of changing everything that I did. I was in a really big school where there's over 900 children in the school I was in. So there were two of us went on the course. We had a fabulous time. We learnt loads about teaching science. From that, I won an award with the Primary Science Teaching Trust and became a fellow of the Primary Science Teaching Trust. And then I joined the ASE, the Association of Science Educators, and got involved in various committees and things like that with the ASE. I went down to their big annual conference every January and started, speaking at that and started writing for primary science. And from that, just lots of opportunities came. I realised that there was this incredible primary science community out there doing lots of things. We did our primary science quality mark twice while I was at the school, and just discovered a real passion for teaching children science. And I discovered as well that I really enjoyed supporting, mentoring, coaching other teachers to do the same. And I've still got in my school email inbox, I've still got some lovely emails that teachers sent me going back 15 years now, as they retired, about the impact that I had on their teaching practice. And for me, that's that's kind of the ultimate thing. And then just before lockdown, a friend of mine, Bryony Turford, who's a primary science consultant down in England, and I had the opportunity to write a book for Bloomsbury, 101 Ideas for Teaching Primary Science. And we really enjoyed working together. So we were then looking for another project to do together. And we've both always been passionate advocates of extracurricular activities, particularly in science and running science clubs. So we decided to set up and found My Science Club, which is a small company that produces really high quality resources to support teachers running a science club or a STEM club in their school. And we've been going now for a couple of years, and we've just made so many connections through it. We've had so much excellent feedback from it, and it's just been great fun. For us, it's not really, I mean, ultimately, we'd like to make a little bit of a retirement fund for ourselves out of it, but it's not really about making lots of money. It's about really enjoying working together and enjoying producing something that we can see has a huge impact on lots of teachers in lots of schools across the world. So, yeah, so I keep myself busy. I enjoy lots of things, and I've been really grateful to the primary science community across the UK and increasingly internationally for giving me great opportunities whenever I need them.
Wow, brilliant. So that's quite a journey there, Paul. The first thing that comes to my mind there is how do you balance it all? Like, do you feel that you get enough time with the kids as well as, making impacts with the teachers?
Yes, I do. I've done it in different ways over the years. I've had years where I have taught science across the school, sometimes from primary 1 all the way through to primary 7, and sometimes just across a few year groups. Had years where I've gone into classes and team taught with teachers, which is really rewarding. It's a very different way of doing it, but it really upskilled the teachers. Whenever I'm in a school, I'm all about the sustainability. I'm all about what happens when I leave. Is the school going to be in a better place when I leave? So my previous school, I was there for 10 years. By the time I left, I'd kind of worked and trained up and mentored 3 other people who then took over running science across the school. And the school just went from strength to strength because of that after I'd left. In my current school, it was more about re-establishing STEM and getting STEM back on the radar. My role at the moment, I don't have my own class. I teach across primary 5, 6 and 7, and I'm teaching sustainable engineering this year and looking at ways of bringing lots of different areas of the curriculum together. And it's very new for me. I'm very much out of my comfort zone with it, but it's been absolutely fascinating. It's about upskilling the rest of the staff because this isn't going to last forever. Plan is that I'll maybe do another 2 years of this and then move on to something else. But by that point, I need to have the rest of the staff confident with being able to take it on and making sure that the hard work we've put in place doesn't just stop. So the sustainability of it in the school is really important to me. And that starts, I think, with getting other teachers passionate about STEM, getting other teachers knowledgeable about STEM and about what they're teaching, and making sure that they have the resources to hand to be able to do it and that they're not scrabbling around or trying to fix broken equipment or anything like that. So that part of it's really important. I almost do a reflection every time I teach a lesson and keep that log. And then that's going to be the foundation then for training up the rest of the staff to be able to do it across the school and make sure that it's a legacy. Time wise, I've always felt if you're really passionate about something and if you can see the impact you're having, the time isn't a problem. I do lots of stuff, admittedly, in my own time, but it never feels like work because I love what I'm doing.
Good. Okay. So before we get into the serious stuff, I just wanted to do our quick fire 5 rapid fire question round. So I'm just going to ask you 5 questions and then you just give me the first thing that pops into your head. Are you feeling ready?
Yeah, I think I'm good.
Okay, right. So question 1, who is your favorite scientist of all time and why?
Rosalind Franklin.
Okay.
her work on DNA. She was an absolute inspiration to me growing up. I loved the fact that she was relatively unknown at the time I was growing up, but she worked in what I wanted to be my field. And I think one of my uncles had given me a book about Rosalind Franklin, which I've still got, and I still go back and read from time to time. But yeah, absolutely phenomenal role model.
Fantastic. Okay, so question 2. If you could recommend just one must-do science experiment for primary students, what would it be?
Lemon batteries
The lemon batteries.
is an absolute favourite of mine, and it's an investigation that I developed when I was in my previous school, and doing it with a voltmeter lets you then look at lemons in series. It lets you look at different citrus fruits, so you can build all sorts of investigations in. You can look at different electrodes and using different metals as electrodes, and it's just absolutely fabulous, and the children love it, and it's one that I try and fit in somewhere every year.
Okay, so question 3. What is one science fact that just blows your mind every single time you hear it? If there is one.
So I think one of my favourite ones is the fact that the adult human is made up of around about somewhere between 28 and 36 trillion cells. But we carry on us and in us about 39 trillion bacterial cells. And I love the fact that we're basically just huge walking bacterial cultures. And I think as a biochemist who spent a lot of my research time growing bacteria, that's a fabulous fact.
Yeah, we're more bacteria than we are human. Okay.
Yeah.
Okay, so question 4. What's your go-to resource for science teachers? So that could be digital or physical.
I think my go-to physical resource is a microscope. I think having a digital microscope should be something that's in every classroom, and accessible for children kind of all the time. Digitally, it would be the Primary Science Teaching Trust's suite of resources, which are absolutely fabulous and free for anybody to access. And as an annual thing, it would be the Great Science Share, and to encourage schools to get involved with the Great Science Share in June every year.
Oh, okay. I haven't heard about the Great Science Share. So question 5. If you weren't in science, what might you be doing instead?
I think if I wasn't in science, if I wasn't in the sort of teaching of science, it would either be rugby coaching, or I'd love to have been a Lego designer.
Nice.
And I think, if I had my time again, if I'd managed to find my way into the Lego design, that would have been my ultimate job. And I'm sitting here in a room absolutely surrounded by Lego at the moment.
Oh, brilliant. Okay, very, very cool. And I wanted to ask if you'd be willing to just walk us through each of those skills. Would that be okay?
Yeah, absolutely. That would be brilliant.
Brilliant. And so before we start with that, could you help us to define, so what are the inquiry skills, as it were? Like, how would you name them?
Okay, so I think the starting point is to understand that science inquiry and the inquiry skills are how we know what we know about the world and beyond. They are basically, and always have been, since even before they had names, they are how science works. And whether you are working at NASA, or whether you are at the cutting edge of antiviral technology, you are using those inquiry types. And I never really realized this as when I was working in science, because it's not talked about, but that is what we do as scientists. So I think the simplest thing to say is that inquiry-based learning, science inquiry, is how science works. By extension, then, it's by using them in class and by making children aware of them, you're giving children the opportunity to be real scientists, to carry out investigations in exactly the same way that a real scientist would. It's also a great way to introduce lots of skills to children and get them working on lots of skills that they're going to need to be successful in their science. It's about giving children opportunities to do practical science wherever possible and looking for those ways, whatever the topic you're teaching is, of how can we bring the practical into this. As they get more experienced with it and as they understand the four types or the five types of science inquiry, they then start to take control over the planning of their inquiries, choosing which is the most appropriate method to use. And you can almost get to the point by the end of primary school where they're running the whole thing themselves. They're coming up with the questions, which is where inquiry, it's where science starts, and they're taking it right through the planning process and through to getting some results and finding a conclusion. So the five types, which we'll go into in a bit of detail in a bit, of your comparative and fair testing, your pattern seeking, observation over time, identifying and classifying, and researching using secondary sources. Now, the researching one, there was a discussion a few years ago about maybe getting rid of that one, and a group of us were brought together as consultants, and I said, absolutely not. I said, because that is where every scientist in the world doing research will start. First thing they will do is a literature search to see, well, has someone done this before? Has someone done something similar? What can I take? So for me, that one's absolutely critical in terms of the inquiry types. And as a skill to teach children, it's something that I'm not convinced is taught particularly well in schools, that idea of being able to do a search of literature, pull out key information, verify it, check it, what are the sources, is it reliable, and then base a question or an inquiry on, what you've read. So for me, it's absolutely fundamental in science teaching, in the same way that it's absolutely fundamental for a researcher working in a laboratory somewhere.
Have you got any tips and advice or stories from your teaching about how you can bring that to life for the students? Like, how do you kind of finitely teach that skill?
So the researching is about accessing scientific information that already exists, that somebody else has gone out and found, either to get background information before you start, or to help explain results that you've found from an inquiry. It's also a brilliant way of showing the evolution of science over time, and how science works, how science changes what the facts are as it finds new evidence. And I quite often talk to the children in school about things that I was taught when I was at school that we now know are just not true, or have changed. And one of the best examples is Pluto. When I was at school, Pluto was a planet, and now it's not. And there are lots of little examples of that, of things that we were taught when we were at school that we now no longer know to be true. And having a look at things like, plastic is another great example. When I was at school, I remember, plastic was, and particularly sort of single-use plastic, was just coming into use. And it was seen as an absolute wonder material. It was seen as, this is going to save the planet because it's going to save, we're not going to have to chop down trees to make paper because we've got plastic. We're not going to have to, mine metal from the ground because we've got plastic. And we didn't at that point have any idea of the problems that single-use plastic was going to cause, and the way that single-use plastic was going to degrade. And it wasn't until we built up over time that evidence base that we were able to say, actually, this isn't the wonder material we thought. We need to be very careful about how we use it. The other great example, I was actually chatting to a class the other day because we were looking at insulation, and we were using the thermometers, and one of the children said, "Our thermometer's not filled with mercury." And I said, "No, they're not anymore." I said, "They're now filled with various different solvents." But I said, when I was at school, they were filled with mercury. And I was telling them a story about, it was always great fun in the chemistry lab when a mercury thermometer broke and you had a little bit of mercury to play with on the table. And I said, at that point, we had no idea just how dangerous mercury was.
Yeah.
And it wasn't until the research was published, around that time, that actually people said, well, you can't use mercury in schools. So science evolves, science changes, and through research, you
Mm.
can find that. Top tips wise, it would be books. Don't do everything online.
Yeah.
Whatever your topic is, try and find a good selection of books to have in the class. Children love looking at books. They love the opportunity, and there are so many good sort of non-fiction topic-based science books aimed at children. So I would always manipulate my library in class. Um, Teaching children how to search online, teaching them how to properly use a search engine, teaching them the key aspects of critical literacy, checking for the source, checking for reliability. Who wrote
Mm.
it? Do they have an agenda? Particularly if it's around a kind of not a controversial topic, because they shouldn't be controversial, but they occasionally are, like vaccines or like fossil fuels, energy production, climate change. It's really important that children are taught those critical literacy skills to be able to make their own judgments.
Mm.
There's fabulous opportunities for getting data online now. There is air quality data from pretty much across the world. There is weather data globally. You can look up online, weather data from 30 years ago and compare what the weather was like then with what it's like now. You can look at energy production data. Certainly in the UK, you can literally go online and it will tell you at that precise moment how the energy is being produced across the UK. And you can do the same across Europe. You can do the same across the USA. I'm not sure if every country has it, but it's something that's a really valuable data source. So you can find this. The website, the Worldometer website, is
Okay.
fabulous,
Mm.
which gives you data sets on population in real time. It gives you data sets on social media use in real time, and it's a fantastic way for children to be able to see different sorts of data and use different sorts of data. And I think that's really important as well when we're talking about that research
Mm.
bit of it. So I would say don't discount research ever. It's a really important skill for children to learn and to understand what it is, how it
Mm.
works.
Absolutely. So you mentioned there that so you use resources like the Worldometer and real data online. So when you teach that, would you advise us to teach it on its own with a very, very simple concept so that the students can focus on the idea of research? Or would you prefer that the students do it as part of the curriculum and you kind of weave it in to the topics that they're doing?
Yeah, I would teach critical literacy as part of English curriculum. And
Okay.
yes, I would use really simple contexts to start with
Mm.
to introduce it and introduce the different concepts. And it's something I spent quite a long time a few years ago developing resources to be able to do it. I think particularly as we've moved from kind of mass print media to mass online media, it's become more and more important.
Yeah.
Um, and there's certain sort of skills there, like checking the sources. Can you verify this information in at least two other places online?
Mm.
Having a list in class of kind of go-to places that are generally reliable.
Mm.
Understanding that things might change as more evidence is found, and that goes the same for
Yeah.
the news as it does for scientific research. In terms of teaching children how to use the internet and how to use a search engine, again, I would teach it sort of step by step, um, really simple things to start with. So I would say teach them in isolation through simple context, and then look to put them into the context that you're wanting the children
Yeah.
to use them in.
Yeah.
Um, Children, I think, also need to understand that the world is a very complex place and science doesn't exist, just on its own. And with older children, you can have really good discussions about this, how science is impacted massively by money, by society, by governments, politics, and increasingly by global politics in a way that it never used to be. So I think there's a huge amount in there to unpack, and
Yeah.
across a child's primary school career. So, 7 years in primary school or 6 years in primary school. It's about building those blocks and getting towards an end point and almost kind of knowing what you want at the end. And then
Yeah,
looking at, right, how are we going to get there? How are we going to get the children to have these skills? Because these are the fundamental skills that our children are going to need moving forward, whatever careers they go into. These skills are absolutely fundamental.
absolutely. Yeah. I wonder, Paul, could you give us an example of what teaching research skills in isolation might look like, say, in a year 2 or a year 3 class?
Yeah, so with younger children, it can be about getting them to find a very specific image online. So you might say
Mm,
to them, you're going to find a image of somebody walking their dog on a beach with the sun setting behind them. And so they need to then really think carefully about, right, what do I need to
mm,
put into the search engine? What are the key bits of information that I've been asked to look for? And how can I find it? I used to do activities as well where I would show them a picture that I'd found on the internet,
mm,
and they had to find the exact same picture. And so they had
mm,
to look at the picture, they had to pick out, right, what are the key details in this picture? And then I'm going to put those into my search engine. So you start off with really simple things. So you might ask them to find, a picture of a black and white cow standing in a field. Really simple to start. And then you get, as they get better at it, as they improve, you get more and more complex in terms of what
mm,
you're asking them. And what I used to do, again, just for good practice, is I would get them to save the picture into a PowerPoint presentation, and then underneath it, they had to paste what they had searched for. So exactly what they'd put into the search engine.
okay.
So you're developing a whole load of skills there. Being able to copy and paste and all these skills that I think we take for granted quite sometimes as
Mm,
adults, but actually children needs that teaching. And you can get into really complex searches that you're asking them to do based on very, very specific
mm,
information that either that you're giving them or that they've got to pull out of an image. So images are the best place to start. And from there, you would take it on to giving them questions that they'll be able to find the answer on the internet. And then they have to go and find the answer to that question. And again, year 2,
mm,
year 3, those will be quite simple questions. What is the sun made of? How far away is Jupiter?
yeah.
Quite simple questions that they can start with. But they're having to work out, right, how am I going to put this into the search engine? And then is there a simpler way of putting it into the search engine? If I just put Jupiter into the search engine, do I get that answer?
Mm,
Or do I have to be more specific that I'm looking for the distance? If I find the distance, and then what you can do is you can then say, right, you need to find the distance of Jupiter for me on 3 different websites. Do they all give you exactly the same answer?
okay. Mm,
And you can tailor it to whatever whatever your class's topic is or whatever their interests are. You could do it around football and football players, and you could do it around dancers or singers. You can create those questions about anything, but getting them to find that information in 3 different places
mm,
and check, is it the same information in all 3 places? And if it is, then you can be fairly confident that that information is right. And it could be, I don't know, where does Taylor Swift live, for example, would be a topical one just now.
yeah.
And, they then have to find out, right, and how accurately can we find that information? Can we find her exact address, or can we just find the city that she lives in or the country she lives in? And so as the children get older and older, you're refining that, you're adding layers of complexity to the questions that you're
Mm,
asking. You can tackle some pretty big topics through it. We've had, as I know, it's happened almost globally, massive increases in terms of our fuel costs in the UK. And so one of the things that we asked the older children to do a few weeks ago is they were looking at, and I was like saying, well, what profit are these companies making? And has
mm,
their profit increased as they've increased fuel prices? And so they were on Googling and they found information from all sorts of different websites, and some of it said one thing, and some said another thing, and So they then had to start comparing and saying, right, well, which one of these is most reliable? Which one of these do I believe? So looking out for stories like that come up that you think, I can use this. I can use this to teach this skill. I think is really.
Mm. Brilliant. Have you ever kind of gamified that? So maybe at the start of a lesson, maybe the first 10 minutes or so, you could choose something that is current in the news or something the kids would like, depending on their age, and then get them to learn those skills, those inquiry skills, whether it be research or analysis or making predictions in a quick 10 minutes, or do you find it needs a full lesson, a full hour lesson?
Certainly with older children, I'll quite often do it as a starter activity when they come in, and as a settler, and they'll work in pairs or work in threes to do it. And you can, 10, 15 minutes with a question, and literally just put a question on the board. What do you think? They have to go online and find the evidence to justify their opinions about something is another really good way of doing it. We used to do lots of debating in schools, and you'd give them all sorts of questions where there were definitely two opinions or more. And again, it was about them finding evidence online or in books to justify their opinions and to be able to back up their opinions. So yeah, absolutely. I think putting it into different scenarios and little real life scenarios is a really good way of doing it.
Nice. Okay. So you mentioned for the older kids, those little starters would be better, but for the year one, two, three.
I think down the school, younger children, you really need to focus on it. And it might be that your focus on it is only for the first 15 minutes of the lesson, and then you're letting them go on something else. But you're doing that at the start, but it's more focused at the start. And I think it's one of those areas where there needs to be a bit of there needs to be some modelling from the teacher. There needs to be some teacher-led input at the start as well.
Yeah. Much more guided, kind of
Yes,
like a
yeah, that's a
guided
better word, actually. Yeah,
practice. Yeah.
yeah,
Yeah.
definitely.
Okay. Nice. Thank you very much. Okay. So that's research. I guess one that ties in really well with that is questioning. So in order to do your research, you need to come up with these questions. Is there a way that you go about implicitly teaching the students how to question, how to figure out what the best question is to get the best answer?
Yeah, I think again, there's a lot of modelling from the teacher, a lot of kind of co-creating with a class or a group. So I'll usually work on kind of mini whiteboards where they can rub out and change quite easily. I would get them to work in pairs or in threes and just come up with what they think are the questions that they're wanting to find the answers to around a particular topic. And then it's a case of taking a selection of those, and I would go round as they're doing it, and I'll make a mental note. Right, Daniel's got a really good question. Jane's got a really good question. I'm going to definitely ask them to share theirs, even if they don't put their hands up. And that's about collecting those questions together, and then looking at, right, how can we put these two questions together to get something that's a bit more complex and a bit more in depth. Or how can we rephrase this question? I do a lot of work in science about rephrasing children's questions. There are times when they'll come up with a really good question, and just changing one word or just changing the emphasis of the question makes it something that you can then set up an inquiry around, or that they can research around. And it's one of the things that the Great Science Share focuses on: children's questions and then how children answer those questions. So it's a really good initiative, and well worth checking out the Great Science Share website for any schools and getting involved, because there's lots of resources on there to support teachers getting children to ask really good scientific questions. But it's a real skill, asking good scientific questions, and it's a skill that needs to be taught.
And it sounds like the way you do it is this natural way to engage the kids. It doesn't feel stilted at all. They're asking questions, they're coming up with things that they want to know about a particular topic all together. Is that the aim?
Absolutely. It needs to be organic. It needs to be dynamic in the class. I used to have a question wall, and there was just a big pile of post-it notes at the bottom and a pencil. And it meant children could go at any point. If a question popped in their heads, they could go and write it on the post-it note and stick it up on the wall. And we used to have one for our topic, and we used to have one for just general science questions. And it meant they didn't need to disrupt the whole class by asking the question that popped in their head in the middle of a reading lesson. They could just go and write it down. And then we would come back to those questions. And some children took questions home to answer them and then came and presented on them. Other ones we found out the answers in school. So, yeah, you need to give children opportunities to ask those questions, and then take the best ones of them and look at, right, how can we rephrase this question so we can turn it into a fair test inquiry, or so we can turn it into something that we can actually investigate.
And then, so following on from that, what would you say is the next inquiry skill? So you've made a question, you've done some research.
Yeah, so I suppose the next one is about making predictions and hypotheses and getting children to use information they've already got or use information from their research to then say, well, I think this might happen, or I think this might happen. And again, it's a case of creating the culture in the class where children are happy to do that and have a go at that without fear of, you're wrong. And it doesn't matter if our hypotheses are wrong or our predictions are wrong. So I think moving from questioning through to the hypothesis is a kind of natural progression.
Brilliant. One of the major issues that comes up a lot is about teaching the measurement skills, right? Those hard skills when you're testing. So, using measuring cylinder correctly, scales, and all that kind of thing. Do you have any hard and fast rules about that, about the testing phase?
Just practice, really. Just practice in lots of different contexts. The younger children, they don't need to be measuring accurately. They just need to be starting to use the equipment, get the hang of it. Where do I want them to be by year 6? What do I want them to be able to do? And that's then what you're building towards. And as they go through each year, you're teaching them to become more and more accurate with their measurements. Use a stopwatch accurately. There's different types of measuring device for length. A meter stick to a measuring tape. And when would we use those? Selecting the right tools is really important as well. So, can you measure the circumference of somebody's head with a meter rule? No, you need to use a tape measure. Can you use a joiner's tape measure? No, it doesn't go around very well, so we need to use a tailor's tape measure. Little things like that make a massive difference. Then insisting by the time they're in, year 5 into year 6, really insisting on accuracy with their initial measurements, accuracy with their measurements of results, helping them to understand, the accuracy. So repeating results, show them that if you repeat your results, you get more reliability. But you have to be accurate with each repetition. You have to do each repetition in exactly the same way. Otherwise, your results, pretty much meaningless. Just lots and lots of opportunity in lots of different contexts. Whether it's, when you're teaching maybe volume during maths, you're relating that to the science as well. You're saying you're going to use these skills when we're doing XYZ science topic and XYZ science investigation. I suppose it's the way that any of us get better at any of these things. It's just by doing it over and over again. I think that data collection bit is so important because that gives you the opportunity to take science to the next level in primary schools. It no longer, I think, for a long time, and this could easily be another whole podcast, but I think traditionally science in primary schools was very observational based. It was do something, observe it, and then talk about what's happened. And I think if we can change that and make it much more about, we collect data from as many of our investigations as possible. I mentioned earlier doing the lemon batteries, and I changed very early on from trying to get an LED to light up to attaching it to a voltmeter. And straight away we were able to then get numerical data from our investigation. And that let us then compare, can you get more volts from a lime than a lemon? Does iron and copper work as well as zinc and copper as your electrodes? And you were able to do direct comparisons then because we were collecting that numerical data. I've done the same with our sort of reflections, our light and reflections topic, where instead of the children just judging by eye, oh yeah, that one looks like it's reflecting better than that one, we use an app on the phone. We use a light meter app on the phone to actually measure the reflected light. And it's just taken that whole investigation to a new level. And there's so many tools that you can teach children to use, light meters, sound meters, which are built into any phone or any tablet. So I think that can be really important.
Brilliant. And so whilst they're focusing more and more on accuracy, it still all sounds like it's mostly self-led. So, for example, for the younger kids, do you measure your head with a meter rule? So would you give them lots of different measuring tools and let them lead that? Or?
Absolutely. I would give them a question like, do children with bigger shoe sizes have bigger heads? And I would literally put out a whole range of things, from a normal classroom ruler, a meter stick, a trundle wheel, tape measure, and let them choose the tools that they're going to measure with and get them to measure the heads. And some of them will measure the heads in different ways. Some of them might measure it around this way, from top to chin. Some of them might measure it the way that we want, which is around the circumference of the forehead. Some of them might, they might find all sorts of different ways to measure, but it's about them finding the tools, the correct tool to be able to measure what we want them to measure. It's about those opportunities, and there's lots of these little investigations you can do. Do people with long legs jump further than people with short legs? Is your hand span linked to your shoe size? There's lots and lots of different ones you can do. So it can almost be that every year they're doing something completely different. That gives them those opportunities, and they are real life opportunities for them. They're getting that opportunity to choose the tools, be accurate with their measurements, and actually then you can look at drawing a graph, drawing conclusions from what you've found. So it's just about opportunity and practice are the two main things.
Yeah. Like, how often do you do an inquiry in class?
I would be looking to do an inquiry probably every 2 or 3 weeks. I would want them to be doing some sort of investigation, some sort of inquiry. Between that, I would be then teaching specific skills that they needed, or looking at the science behind it, looking at them, getting them to draw conclusions and talk about the science behind what they've been doing. But I want them to be doing something every couple of, or at least every 3 weeks, and it might be something really simple. Looking at dropping different types of ball and seeing how high they bounce. And it might be that's the start of our lesson, and then we move on to what we're looking at. And there are so many sort of little simple ideas that you can do linked to what you're teaching, linked to a topic, or linked to the science that you're teaching them.
And that leads us to the last skill. The whole purpose of the inquiry is to get that conclusion, or to answer the question that you've initially asked. Do you have any final advice for us for when it comes to teaching conclusions?
Yeah, I think, again, it's about creating a classroom culture where children are happy to give you an answer without fear of somebody telling them that they're wrong or laughing at what they're saying. I think it becomes much easier when you've collected some data and you can see that data and you can plot them on a graph, or you can put them into a spreadsheet and organize them and do sort of some pattern seeking on the numbers. And it's about getting children maybe to go either back to their research, or then doing some research at that point on, right, so how's this worked? Why has this worked? How have I managed to get electricity out of a lemon? What is going on there? And really relating what they've found from their practical inquiry, from their investigation, back to science that you're wanting them to learn. And I think, again, just lots of opportunities with really simple investigations. Do people with long legs jump further than people with short legs? And if you can do lots of these little simple investigations, children will just naturally get used to making a conclusion. Well, we can see from our results that actually leg length makes no difference to how far you can jump. Does age relate to how tall you are? Well, we can see in our class that actually, yes, the tallest people are the older ones. Is that the same in all classes? And you could then do a whole school investigation and get every class in the school and look, well, by year 6, it doesn't make any difference. Whereas in year 1, it makes a big difference. So you can do it in so many different ways, but lots of these just simple little inquiries that are teaching children those vital skills of measuring using different things. We did one which was looking at sprinting speed, and we were looking at a number of different measurements to see if anything related to it. So we looked at shoe size, looked at leg length, and then we timed them sprinting. And so straight away you've got them measuring the length of their legs. So how do you do that? Is everybody in the class measuring their legs the same way? They're measuring out the course to run over. So they're straight away they're using a tape measure, and then they're using a trundle wheel or a meter stick, and then they're timing each other running over that distance. So you've got your stopwatch skills and recording the time accurately. There are so many of these little investigations that you can do really, really quickly, really simply, that reinforce so many of the skills, and they take you right the way through from questioning, hypothesis. Well, half the class thinks that people with long legs will run faster. The other half think that they won't. There we go. Brilliant. We've got 2 opposing hypotheses that we can go and test. We do the data collection, the analysis, and then through to the conclusions. Well, actually, we found that leg length makes no difference to how fast you can sprint. So we need to go back to our hypothesis or back to our questions and say, right, what else might make a difference? So is there something else then that we can test that we can then start the whole process again? And you could almost do it on that one activity. What is it that makes someone a good sprinter over 30 meters? You could almost do a whole year's worth of different investigations and looking at different things. Vertical jump, standing long jump. How do they affect sprint speed? Showing children that cycle, because it's important for them to realize that science is a cycle. It's not a linear thing. We don't just go, here's a question, here's a hypothesis, here's an answer, stop. That then leads on to something else. And that's why I love those simple investigations, because they can always lead on to another question. It's like when you're growing plants is a great one. And we did an investigation a few years ago where we sorted the seeds. I think we were doing runner beans, and we sorted the seeds by size. And we wanted to know, right, do the bigger seeds give you a faster growing plant or a taller plant after 6 weeks? And again, that led on then to so many other questions. When we got our results and we'd drawn some conclusions, it led on to a whole other set of questions. So I think it's the drawing conclusions is important, but it's almost as important that then leads on to other questions for them. Like all the best things in the world and in nature, it's a cycle. Science is a human construct, the idea of science, of finding out things, but it's almost as if the cyclical nature of it is almost as if it was here just waiting for us to discover, like most things. And actually it's just always existed. And I think when you look at the history of science and you think about those first Homo sapiens flying out under the stars, asking questions about what was going on and making hypotheses based on the evidence that they had, and you then look at where we've come to now, you can see that cycle in practice. And I think showing children that can be really, really powerful.
Yeah, I think it's really powerful to look at science in that way, that it's actually a natural thing that humans do. It's just the way that they learn, and we're just putting a construct onto it. So by keeping things simple, asking questions about things that they want to know or things that are real to them, can be a really powerful way to teach it. And I think we get so tied up in the curriculum, and we have to teach them, all of these different things, all of these objectives, and that very simple part of it is perhaps not as much in the forefront as it could be.
Yeah, absolutely. And I think, certainly One of our challenges up here in Scotland is our science curriculum is so packed. There's so much content there, and people do lose sight of the importance of the inquiry and the importance of that. Actually, it's really about those inquiry skills. That's the key to it. Teaching a bit of the content is important, but actually teaching children those inquiry skills, because not all these children are going to go on and be research scientists in the future. But if they have that way of thinking, that's going to stand them in good stead, whatever they go on to do.
Yeah. Paul, such a valuable conversation today. Really do want to thank you for the practical advice, the insights, the stories, and for your time.
No problem at all. It's been an absolute pleasure. It's been really good fun to chat through all that with you.
It really has been fun. Do you have any other final tips for teachers who are just starting out with this, or who maybe want to learn more about inquiry-based teaching?
Yes, I think in terms of learning more, I think that's the key. Go and find out more. There's a brilliant book from the ASE called It's Not Fair, or Is It?, which was written by Jane Turner and Brenda Keogh and Stuart Naylor and Liz Lawrence. And it's actually just been updated, but the updated one isn't quite published yet, but look out for it. But it's basically the Bible of science inquiry. It's an absolutely fabulous book. I mentioned a couple of times already the Great Science Share. The Great Science Share is brilliant for developing these inquiry skills, because the whole idea of the Great Science Share is children come up with their own inquiry. They come up with something they want to investigate, a question they want to find the answer to. They do the investigation, and then they share their answer with a wider audience. And it's all set up for children, for schools across the world to share their answers with each other and talk about the investigations that they've done. This year's theme, or next year's theme, because it's in June, is all about the sort of natural world and looking at mini beasts and invertebrates and things. So it'll be a fabulous opportunity. I think the key for me is around the practical science, and practical science doesn't need to be, lots of equipment, really complicated experiments. It's really simple stuff, and it's really simple stuff where you can teach those core inquiry skills through it. And those core inquiry skills, although we talk about them as scientific inquiry skills, they're just inquiry skills. And whether you go on to be a journalist or an author or whatever in the future, you're going to use those same inquiry skills in some way. They might be called something slightly different, they might look slightly different, but they are the same core skills. And so teaching children this process is as important as getting through the curricular content and the scientific knowledge content. And I think that's somewhere where teachers need quite a lot of support sometimes to do that. They also need the go-ahead from the school's leadership team to be able to have the confidence to do that and not just work through a series of lessons. One of the reasons that Brian and I set up my science club was there are so many off-the-shelf curriculums and things out there that are very worksheet-based and are very kind of dry, and here's a PowerPoint and here's, a video about it. And we wanted something that was really practical. So we've got a lot of schools that use my science club. They use all of our practical stuff to sit alongside their curriculum that they've maybe bought in. It's been really valuable for that. And it is all, it's all about developing those inquiry skills. It's all about the practical side of things. I would say to teachers, if it's not your comfort zone, just try it, give it a go, because as soon as you do it with a class of children and you see the enjoyment, you see the learning, you see the active learning happening, you'll be converted, and you'll never look back.
Those are some excellent closing words there. Thank you so much, Paul. It's been an absolute pleasure.
No problem. Well, thank you very much for the opportunity. I've really enjoyed it, and quite a privilege, I think, to be able to share.
Okay, wow, what an episode. So Paul really went into a lot of depth there and gave us some fantastic ideas on how to implement inquiry-based learning in the classroom. So the main takeaway for me is that when teaching those inquiry skills, we shouldn't be afraid to just go off topic and implicitly teach the science skills themselves. All you need is a simple question or an idea that the kids would find interesting, and then just go from there. Keep it simple and keep it fun. Thanks for tuning in today, everybody. Keep asking questions, keep exploring, and I will see you next time on the Primary Science Podcast. Bye for now.